Alright, welcome to Elk tutorial for site modeling. Elk is a program for Grasshopper built into Rhino that will allow you to use open source data from OpenStreetMap and NASA's Srtm data to get topography models and street data where applicable. So what we're going to do today, we're going to use the Pittsburgh site that we're using for the rest of the Beehive workshop on site modeling, and I'll show you how to work through that. So the first step is to open up Rhinoceros and then to start Grasshopper. If you already have Grasshopper installed, all you need to do is type Grasshopper into the command line and it'll load. In this case, it'll load over the full screen. You can align it wherever you want. One of the most helpful things is if you make this full screen and you leave this here in the corner, you can pull this down and then you can pull this all the way down. And this allows you to work in the perspective and in Grasshopper at the same time. For this, we don't really need Rhino open, as all of Elk will begin in just Grasshopper, so we can keep this full screen. You'll probably start here on the params view, and we'll flip through a couple of these as we need them. If you don't have Grasshopper, you can go up here to grasshopper3d.com and then go to the download section and download the latest build. If you have Rhino 5, you can download this one. If you have Rhino 4, you can download this one. And like it says, you'll need the most recent Microsoft runtimes to be able to load Grasshopper and Rhino 4. From there, to get Elk, you want to go to foodforrhino.com. This is the best site to download, well, really the only site anymore to download the plugins for Grasshopper. It has all of them down here for Grasshopper and Rhino ones as well. You can play with the rest of them. You'll have to log in and create your username, and then we can come down here and click on Elk. When that loads, there'll be a list of downloads at the bottom of the screen eventually. And you come down here and you can download the latest one. When you download it, when you click download, it's just going to give you the GHA file. And all that means is you want to show in folder, find this folder, come up here, computer. You want to go to where your Rhinoceros file is, usually in program files x86 if you have 64-bit, or just program files if you're 32-bit. Come down here to Rhino 4, plugins, Grasshopper, components, and then you'll see these other green GHA files. You can just click and drag this right in here. Once you have that installed, it'll load in Grasshopper. Make sure you close Grasshopper and Rhino if you have it open, and just reopen it once you install it. So once you have Elk installed, we're going to come over here, come to Extra, and you'll see these are all the pull down components. We're going to use most of these, but we'll start with the location data. So the location data is organized by streaming large amounts of data, the file path, the longitude and latitude, and the scaling factor. So what we need to do is we need to give it a file path for an OSM data. And what OSM means is OpenStreetMap. Therefore, we need to get the OpenStreetMap data from openstreetmap.org. You can either go directly to openstreetmap.org, or you can just Google OpenStreetMap. It'll be the top one, I believe. And then you can type in whatever you want. In this case, we want Pittsburgh. And there's going to be a whole bunch of Pittsburghs. Let's put it in, let's just click Pittsburgh, Pennsylvania. We'll zoom out until we find the tip of the Three Rivers. Zoom into here, you can close this, and what you want to do is click this export tab. From the export tab, you can either manually select the area, which we're going to do, and then you can push and pull the handles to get the area that you want to match your topography that you would have gotten out of SketchUp in the other tutorial, or you can, I'll show you how to get the topography in here as well. So once you have a piece that you like, you can click on this format to export OpenStreetMap XML and then export. And it's going to run through all of the API data, which means it's going to pull out all the points for all of the roads, so it may take a little bit. If you try to get too big of an area, it's going to crash, and it's going to say that you can only query, I think, 50,000 points or something, and it won't let you get that amount of data. So you might have to build it in pieces. But in this case, I believe we can get the whole piece that we're looking at right now, and all of the streets and stuff involved. So what this is doing down here, now you see it's downloading the OSM data, which is the file that we'll need for inside of Grasshopper. When this finishes, save it to a folder that you can access, and then pop back into Grasshopper. In Grasshopper, what we want to do is we need to give it a file path. So there's an easy way to do that. If you go up here to the top bar, in params, primitive, and file path. Again, to click that onto the canvas, I went up here to params, clicked once, primitive, clicked once, file path, clicked once, and then it gets stuck to your cursor. Wherever you click in the canvas is where it's going to drop. Now I can click that and delete it since I already have one. With the file path, what you need to do is right click and hit set one file path, and that's going to take you into your Finder window like anything else would. And then you can navigate to your OSM data wherever you saved it. In this case, I saved it as Pittsburgh OSM. Double click on that. Now your file path is loaded. What's helpful to do is to pull up a sticky note or a panel, put that on the canvas, and then connect these two. This is clicking and dragging, and then releasing over top of the other handle, and clicking and dragging and releasing over top of the P. This just shows you the exact path of your file if you ever need to find it, or it's just helpful to see. Okay. From here we need to adjust the scaling factor. In this case, this is the max, minimax longitude domain. It should set this automatically. This will just be sort of a range, and it'll normalize it, but we can set a scale factor. So what you can do is double click in the canvas, type slider, and click on number slider. This is going to add a number slider to you. What you then can do is double click on the word slider. You can change the name if you want. You can call it scale. You can leave it as a rounding number, and double click on max, and we'll change this just up to 7. Now when you double click in the middle here, you can enter your own value. We're going to enter 3, and then we're going to plug it into our scaling factor. If we pull this over and we zoom out in the top, oops, zoomed out a little too far. Once we plug everything in, we'll have to see how big it is. So we'll leave this back over here. And we'll go, this holds all the points. This is the raw XML data. And then this is your min and max longitude and latitude that we'll use for the topography in a minute. So what we can do is go back into Extra, go back into Elk, and now we can pull out our highways, pull out the major roads, minor roads. Railways and waterways are the same. We won't do railways, we'll just keep waterways. You can highlight all of these, and you can do, this will align them, evenly space them, and this will align them over top of each other, which is kind of helpful to keep your scripts clean. That way you know what's going on. So all you have to do is match the O with the O and the X with the X. So just clicking and dragging, clicking and dragging. It's going to take a minute because it has to run through the information. Click and drag, so on and so forth, until you have all of your data plugged in. The C is just collection type. You don't really have to worry about this. And then what you'll see, this is the motorways, major highways, motorway links, minor highways, trunk links, and then the road key. This is road maps and names that OpenStreetMap data may carry. We won't look at this today, but you can open this up and take a look if you want. It doesn't have all of the names because, again, it's open source, so this is just people adding things on there. But it is helpful some of the time. So now what we do, if we can move this over, what you'll see, if we maximize our top view by double click on the word top, we now have the data as a point cloud, basically. What this is giving you, you can see the 3 rivers, combining the tip, south side, north side, Duquesne, Pitt, if you're familiar with Pittsburgh. And now what we need to do is we need to take this point data and basically make it into lines that we can use in AutoCAD, Illustrator, wherever else. So what we'll do is we'll go back here into Grasshopper, and we can plug, we'll use a polyline component, so you can come up here to curve, primitive, and polyline, which I can't seem to find right now, under spline. I usually just click in the canvas to find it. Oh, yeah, I missed it. Okay, if you go under curve at the top, spline, polyline, click on that, drop it onto the canvas, and then you want to click on the motorways, and you can plug that into V, and then while it's green, if you hold Alt, and then, oops, sorry, if you click and then hold Alt, you can drag to copy it, drag to copy it, drag to copy it. We need 4 of them for the highways. Just plug each one into the V. I'm going to organize this a little bit again. And in this case, we can turn off the point cloud data just by right-clicking and hitting Preview. And now we just have the line data. You'll see highlighted in green. If yours doesn't highlight in green, quick troubleshoot. You can go up to Solution. You can go, now they moved everything, sorry. You can go to Display, Preview Settings, and then make sure your normal is red and your selected is green, or you can change whatever colors you want. You can change it to orange, whatever you like. I'll just leave this at green, a little bit transparent, and we'll go from there. Okay, so what we want to do now is we want to merge all these into a color so that it's easier to read. So what we need to do is double click on the canvas. In this case we can search, and what we'll do is we'll type swatch, and that'll give us our color swatch, and then we'll type preview, and that'll give us a custom preview. What this wants is it wants the geometry and the color. So in this case we're going to change this color to orange and plug that into our shader, and then plug this. And if you want to plug more than one in, you have to hold shift, and you'll see that little plus sign pop up next to the arrow. If you hold alt or control, this is going to give you the negative sign, which will take away. But if I just try to pull this, it's going to overlap it and keep overlapping it. What I want to do is shift and add them all into the G component. Alright, once they're all in the G component, I can again turn all these off by highlighting them, clicking the middle mouse button, which brings you up this little scroll wheel, and then disable preview, the guy with the blindfold. Okay, so now that's a little easier to read in that. Let's continue that process with the rest of them. Again, I can highlight all of this now, click, press Alt once, click, press Alt twice, press Alt a third time. And then you can organize this however you want. We're going to change this swatch here to yellow, and change this one to white, change the waterways to blue. And then what we need to do is just come in here and override these. It's a little confusing with all these lines, but you can just override these ones, and I believe we need 5 of them for this middle one. So what I'll do here, I'll make this a little easier, and I'll delete all these. So now we have 4. We need 1 more for the tertiary roads, and again hold shift, plug that into the shader. Now we can turn this off, and now we're starting to see the roads being built. Copy this. We only need, I think we only need 3 for the minor roads. If you have more than you need, what's going to happen is it'll either turn up red because we can't plug the road keys into a polyline, or it'll turn up orange when there's no data involved. In that case, you can just delete that one. So we'll plug these into the white shader, turn off our roads. Now you can see the blocks and things coming in. Last, go down here to our waterways. That one doesn't work. Plug that one. Yep, just these three. And then we can plug these into blue. Oops. Turn this off. Okay. So there you go. Now in Rhino, this doesn't exist. See, if I try to highlight this, it's not going to work because everything is right now in Grasshopper. It just looks like it exists in Rhino because we've built it that way using these colors. But a good thing to do at this point is obviously to save the document wherever you want. Save it as Pittsburgh data. And now you can come in here. This will be a little slow, but you can change this to, let's say, 5, and it's going to adjust the scale of your whole model. You can leave it at 0, and that's going to give you full scale, but in this case it's going to be gigantic. So we'll just leave it here and keep it how it is. And then what you want to do, if you want to bake this into Rhino, if you want these to all exist, you can either bake these components individually, or what you're better off to do is to group all of them together. So if I want to group the highways together, what I can do is I can just type, well, we'll just do it in primitive. We'll go to geometry, go to curve, and type curve. Now we can plug all of these roads into curve. We can even rename this major roads. And if you click this little paint bucket, it'll go from having the symbol to the actual name that you typed in. So once you have that selected, this will contain all of the curves for the major roads. And you can come into Rhino, go to your layer manager, assuming you're familiar with Rhino. If not, it's this little cake-looking thing up here. You can click new layer, and then we'll type this major roads. Then you want to come back into Grasshopper, click on that, right click, bake, and it's going to give you the option as to what layer to save it on. Click major roads, okay. Now what's happening if I go into a new file, now in Rhino we have the major roads and they exist as actual curves. So what I can do is I can highlight these curves, I can go to File, Export Selected, and I can export them as a DWG. I can export them directly into Illustrator. It'll keep the layers in both of those. You can go to 3D Max, whatever you want. But you need to bake them into Rhino first for them to exist. I'll go back to here. Alright, so that's pretty much all you need to know for the Elk for roads and road data. Obviously not everything is going to show up. There might be a little more in here. But this is just an open source program that you can get quick free data, which can be really helpful for large site models. And again, they'll show you in the other tutorial how to make the massing quickly and efficiently. So you can build these site models really easily. You don't have to search for the data. If we want to get the topography, another open source way to do it is to use Elk and to go through NASA's Srtm data. What we'll do is we'll go back up here to the top and click Elk, go down here to Srtm Topo. We'll put that on here. What this is asking for, we can put this in a while, is the path to the file, which we don't have yet, domain for the latitude, domain for the longitude, and true if it's Srtm1, false if it's Srtm3. And I'll explain that in a second. But what we can do is plug the longitude from up here and the latitude from up here, and we can copy these two down because we'll need to plug this into our P again. What we have to do is we have to go get the Srtm data. So if you go to the internet and you Google NASA Srtm data, the first one will be this Shuttle Radar Topography Mission, Jet Propulsion Laboratory. Click on that. What this is NASA a couple of years ago, I think in 2000, February 2000, NASA basically scanned the whole world and has topography data for I guess the entire world. And you can search by region to figure out where your region is, and then you can query that data to get a height field. However, as a caveat to this, it's not going to be accurate to the level of a building. If you were going to build a house, you couldn't use this data as your topography data, because what it is the Srtm 1, 2, and 30 are the distances away, basically the distance of heights and how accurate it is. Srtm 1 is the most accurate, and then these numbers 1, 3, and 30 are further away, so it's less accurate. So what we're going to do, again, if you missed that, I'll go back. If you're on this main page, Shuttle Radar Topography Mission, come down here to Srtm version 2 released, click on this link, it'll take you to the index. You want to go to version 2, then you want to go to Srtm 1, and then we want to go to region 6, but if you're not sure what region you want, you can go to region definition, and it'll give you the world and then these numbers as to what region you're looking for. In this case, we're looking for 6 because we're going to Pittsburgh. Region 6, and then you want to scroll down until you find your longitude and latitude. If you need help finding it, you can go back to Grasshopper and you can just look here. This is your longitude 80 to 79, your latitude 40.47. We'll go back and we'll look down here to N40 west 80. This is going to download a zip file. When this downloads, you can open this in a couple of seconds and I'll show you. This HDT file is the one that you want, so just extract that and save it in the same place as your other file that you use for Elk. When you have that saved, come back into Grasshopper. You can then change this data, right click, set one file path again, go back and get your HGT data, then plug that into P. This might take a little bit to load, but what it's going to give you is the points as a point cloud, in this case 93,000 of them, and the latitudinal curves. So if I zoom out, since it's going to be at a different scale right now because we haven't scaled it down, I'll go into the perspective and zoom way out. What this is giving me is the topography data as a point cloud. You can, if you just want to see the points, you can double click, type point, plug that in. If you just want to see the curve, you can double click and type curve, and plug that in. So we'll turn off the curves and just see the point data. So you'll see if I look, this is pretty dense, so it's going to be pretty hard to see. I'll maximize this, minimize this. But you can see that the rivers are here. Here's the point. This is the incline hill, and it's pretty accurate. You're going to get a lot of the small little topography things. And then again, you can use the contour model on this if you loft them together. Right now you have the latitudinal curves, but you can get the longitudinal curves, or you can get the vertical section curves if you want to do that. But we can show you that in another tutorial. Sometimes it is weird. This may have been in between two sections. For some reason this one is raised up above the other one. So you might have to do some patchwork. It's just, it has its flaws because it's, again, open source and it was NASA scanning the world from a space shuttle. But it's pretty good, and it'll give you a nice model to work with, to mess around with, and to have for free really quickly. Alright, that I think concludes everything that we'll cover with Elk. Again, if you guys have any questions, post it to psu.digitalbeehive.com. And this tutorial will be uploaded as soon as possible. Hope to see you guys later. Thanks.